Imagine an organism that can withstand some of the most unbearable conditions, a thing that can survive humanly fatal radiation doses and extreme temperatures. This would sound like something from the realm of science fiction, but no. Today's topic of discussion is the tardigrade. First discovered in 1773 by Johann August Ephraim Goes, a German pastor, the specimen was named Kleinwasserbären, water bear, for its bear-like gait observed. The title Tardigradium, meaning slow mover, originated from the Italian biologist Lazzaro Spallanzani. Tardigrades exist across the globe from glaciers to deserts to forests to oceans. Tardigrades are closely related to arthropods, a phylum consisting of organisms such as crabs and scorpions. Tardigrades are a length of half to 1.5 millimeters and are usually omnivores, consuming plant matter or other organisms like tardigrades. Organic life relies on many genetic advantages, known as adaptations, to protect themselves from environmental dangers. The tardigrade is resilient in extreme temperatures from the boiling point of water to below freezing. How does it manage to do this? It has the ability to live in a tun state, a situation like suspended animation, and while doing so, it creates a glassy gel compound, trehalose, around itself. This shield protects it from extreme cold and hot temperatures for years on end without any damage to the creature. Tardigrades can even withstand ice crystallization on their cells due to their unique proteins. Water is an essential resource, but no animal, not even the camel, comes close to match up to the ability of the tardigrade. During the tun stage, a process called cryptobiosis occurs, where the animal slows down all metabolic processes, reducing the need for water. Cells and cellular structures are protected and all activity is suspended by the previously mentioned gel-like compound trehalose. Tardigrades can return to their normal state after conditions are stable once more, whether it takes a week or many years. In addition to slowing down its metabolism, the tardigrade has the trick of relaxing its muscles to allow better intake of water and oxygen when there is a drop in those resources. Interestingly, these little guys can withstand pressures 6,000 times that of our Earth's atmosphere. Tested at the bottom of the Mariana Trench, Japanese scientists concluded that despite how other animals would implode like a balloon, the tardigrade continues without much struggle. The tardigrade is constantly threatened by radiation from its surrounding environment of soil and dust particles. Specifically, when we refer to radiation, we are referring to ionizing radiation. Ionizing radiation, unlike electromagnetic radiation, involves particles that carry enough energy to rip off electrons from substances like how alpha particles and beta particles do. Although not a threat to many large animals, these particles, known as free radicals, released from its surroundings can damage the DNA of the organism. Yet thanks to a handy DUSP protein, a molecule that acts like a shield protects the DNA and increases the DNA's resistance to damaging forces. Therefore, the genetic integrity of the microorganism is preserved. This ability to withstand radiation goes far beyond that of organic particles. Despite what may be assumed, the tardigrade didn't originally have these abilities. According to recent scientific study of the first species of tardigrades, the tardigrade's temperature resilience and radiation resistance were concluded to be non-existent and were hardly an animal fit for any condition. Similar to most adaptations, the tardigrade's abilities do have limitations and downsides. For instance, while in their tun state, tardigrades are vulnerable to attacks from fungi and bacteria. It seems that prolonged exposure to heat also is too physically straining for the organism. In 2007, the European Space Agency exposed tardigrades to space, a place of cosmic radiation and no oxygen. This is significant, as tardigrades may teach us more than expected. In a proposed NASA study, it was suggested that we could learn from this polyextremophile how harsh environments can be survived and how astronauts can heal and seek therapeutic attention for prolonged space exploration. In a 2014 proposed study, it was a prediction that tardigrades would potentially outlive the human race because of their extreme resilience to ionizing radiation and the low probability that the Earth's oceans would boil off. Furthermore, tardigrades were inadvertently left on the moon after the crash landing of an Israeli spacecraft in August of 2019. If we could retrieve these organisms from the moon, we could prove that some earthly organisms have the ability to survive in space for a long time. The tardigrade's ability to survive in a tun state may be useful in preserving organs or even preventing further damage from strokes and heart attacks. Tardigrades are a symbol of what science shows us about adaptations and survival. However, tardigrades are just one of the many examples of how resilient life forms can be. There is still so much that we may learn. Thanks for watching EdHead, and we'll see you next week.